Hi, this is Professor Fernandez, and in this video we are going to work out the volume of a solid where we know the cross sections, and in particular we're told that they are squares. This example comes from the notes from lesson 28 in this Calculus 2 course. You'll find those notes here along with these other resources. So I'll send you first, if you haven't already taken a look at video 28.1 in this playlist. That might be a good place to start if you're new to finding volumes by cross sections. In that video, I do an example of that, and I kind of discuss and talk about the theorem that we use to actually find that volume. So I'm going to zoom in to the right hand side here, and just, you may, if you haven't seen that video, you may want to pause this video and just take a look at this theorem and read it through. We are going to be using this first part, which I discussed in that earlier video, to find our volume. Long story short, the volume of the solid, which I'll tell you about it in a minute when we read it, is equal to the integral of the area of the cross sections. So it's going to be a three-part process. We're going to need to find the area of those cross sections, effectively the area of this yellow square in this example, and then integrate it from x equals something to x equals something, which we'll determine in a minute. So let's go ahead and read through the example. Find the volume of the solid whose base is bounded by the circle this, and whose cross sections perpendicular to the x-axis are squares. Great. So again, this is the second time we will have done this. In video 28.1, I did it the first time around. So I'll speed things up a little bit, assuming you've seen that one. First thing you want to do is you want to draw the two-dimensional version of the region, right? The base of your solid. So this is the solid here, and the region is, the base of the solid is this circle of radius 2. So I'm going to go over here and draw that circle of radius 2. Not a bad circle, that's pretty good. And therefore, that's going to be the base of my solid. Now the cross sections, like the one that's shown here in yellow, we're told perpendicular to the x-axis are squares. So this is x over here, this is y, and notice that this is x, this is y, so it takes a little mental rotation to move things around. But if I looked at a cross section, I'm going to try to get the cross section, try to draw this cross section over here. So if I try to do that, notice that the base of this cross section is perpendicular to the x-axis. Great, we're told that here, and it's kind of close to 2. So if I go over here, and I draw the base of that square, there it is. And now the question is, what is the area of this square? I'm going to call that a of x. It depends on x, right? Because if the base is over here, then we have a smaller square. If the base is on the y-axis, we have the largest square, right? So the area depends on x. So question still is, what is a of x? Well, we're told that those cross sections are squares, and we know that the area of a square is the square of the side length. We've already got one of the side lengths here. This is the base of the square, and then it kind of pops out to become in 3 dimensions the yellow square we see over here. So to find the area of the square, we just need the length here, and then we're going to square it, right, to get this area. So what is this length? Okay, so that length is the same as this length. How can I find that length? Well, it is this y value minus that y value. Okay, and what is this y value up here? This is the y value on the upper semicircle of this circle. So this is y squared equals 4 minus x squared. Take the square root, you get plus or minus 4 minus x squared. So at this point, we can go back and say that, oh, this, I'll put it in a different color here to make it easier to see. This upper semicircle is a positive square root of 4 minus x squared. And this lower semicircle, its graph is negative square root of 4 minus x squared. So therefore, to find the side length, the base length, the length of this yellow line segment over here, we are going to subtract those two. So that's going to be, let's call that b for base length. So that's going to be root 4 minus x squared minus negative root 4 minus x squared, which this minus times a minus makes it a plus, and we have 2 of the same thing. So there we go. That's our base length. So we've got our b. And then now, therefore, the area, because it's a square, is base length squared. So 2 root 4 minus x squared squared, which makes it 4 times 4 minus x squared, which makes it 16 minus 4x squared. That is a of x. In other words, that is the area of these square cross sections as a function of x. So that's cool. So if I were to move the base around over here, get some other square in 3 dimensions, I would know its area. Okay, so now to find finally the volume of this solid, V, we integrate this area function, dx, from the leftmost x extent of the base of the solid to the rightmost x extent of the base of the solid. The leftmost is over here, right? So what is this x value? Well, it's a circle of radius 2. So this is -2. And then the rightmost extent is over here. And what is this value? Well, circle of radius 2, so that's 2. Right? So this is therefore the integral we are left evaluating. This one is pretty straightforward to do. We don't need any fancy integration techniques or anything, right? This integrates to 16x minus 4x cubed over 3, evaluated from -2 to 2. And I will save you all the arithmetic here and just tell you that this ends up being 128 over 3, which therefore is the volume of our solid. Thanks for watching.